There is a tower made from scrap plywood, 2x4s, and a roll of wet burlap that will drop the temperature inside a room by 15 to 22 degrees Fahrenheit, without a single watt of electricity. It costs about $20 if you buy everything new, $12 if you scavenge. It uses no refrigerant, it has no compressor, it has no moving parts, it requires zero maintenance, and it works better in the exact conditions where your air conditioner struggles most, when the air is hot and dry and relentless. The International Journal of Design and Nature published field data on this exact design. Indoor temperature reductions of 8 to 12 degrees Celsius. Passive cooling power measured at 9.6 kilowatts. That is more than a standard residential AC unit. The American HVAC industry generates $130 billion a year. You have never been told this exists. That is not an accident. The answer starts about 2,500 years ago, on the sun-baked plateau of central Iran, in the cities of Yazd and Kashan. Summer temperatures there hit 115 degrees Fahrenheit. Rain almost never falls. And the people who lived there, the Persians of the Achaemenid Empire, had no electricity, no fans, no refrigerants. What they had was engineering. They built towers, tall rectangular towers rising 10, 20, sometimes 30 meters above the roofline. The Encyclopedia Iranica documents them as Badgir's wind catchers. The tallest surviving example at the Daulat Abad Garden in Yazd stands 112 feet tall. It was built before the United States existed. It still works. Here is what the tower does. Picture a tall chimney with openings at the top facing the prevailing wind. When a breeze hits those openings, positive pressure pushes cool air down the shaft and into the rooms below. The building becomes a funnel. But here is the part that matters. When there is no wind, the tower still works. Hot air inside the shaft rises and escapes from the top. That rising column pulls cooler replacement air in through lower openings in the building. This is called the stack effect. The taller the tower, the stronger the draw. To your eye, it is a box on a roof. At the physics level, it is a convection engine that runs on temperature difference alone. Meaning, it does not need wind to function. It needs heat. And heat is the one thing you will never run out of in summer. Now, the Persians did not stop there. Many Badgirs connected to underground water channels called kanats. Air flowing down the tower passed over cool water or wet surfaces before entering the home. Evaporative cooling. The water absorbs heat from the air as it evaporates, dropping the temperature dramatically. Researchers at the University of Kashan documented a 10-meter wet column inside a wind tower shaft, reducing surrounding air temperature by 12 degrees Celsius. That is nearly 22 degrees Fahrenheit. The physics do not negotiate. Evaporation absorbs energy. A wet surface in a dry wind will cool the air passing over it. You cannot engineer around the laws of thermodynamics. You can only pretend they do not apply to you, so the question becomes obvious. The average American household spends $340 to $680 a year running central air conditioning. In hot states like Texas, Louisiana, and Arkansas, the average household spends $550 a year on cooling alone. Over a 30-year mortgage, that is between $10,000 and $20,000 just to keep one room below 80 degrees. A new central air conditioning unit costs between $3,300 and $7,800 installed. A typical system consumes 2,000 to 4,000 kilowatt hours per year, and the cooling industry in the United States alone generates $130 billion annually. A $20 wind tower built from lumber and wet burlap achieves a 15 to 22 degree temperature drop using zero electricity. So why does every new construction home in America come standard with a compressor, a condenser, a refrigerant line, and a $5,000 installation bill? Why has the wind tower, a 2,500-year-old design proven across an entire continent in temperatures exceeding 115 degrees, never appeared in a single American homebuilder catalog? Why do 88% of American households use air conditioning, while exactly 0% use passive wind cooling? You already know the answer. Here is your full build list. You can screenshot this and be at the hardware store in 20 minutes. The frame, 4 8-foot 2x4s, Home Depot, roughly $3.50 each, $14 total. These form the vertical skeleton of your tower. The cladding, one sheet of exterior-grade plywood, half-inch thick, 4 by 8 feet. Home Depot or Lowe's, about $18. You will cut this into 4 panels, each roughly 16 inches wide by 8 feet tall. If you want better heat reflection, use a sheet of galvanized steel flashing instead. About $12 at Lowe's for a 10-foot roll. The screen. One small roll of half-inch hardware cloth, $3 to $4 at any hardware store. This covers the intake opening at the top to keep out birds, rodents, and debris. The cooling medium. Burlap fabric, roughly 2 yards, $3 to $4 on Amazon or at a garden center. This is your evaporative cooling element. You will keep it wet. Fasteners, a box of 2.5-inch exterior screws, about $4. Total cost if you buy everything new, $39 to $43. If you use reclaimed lumber and scrap sheet metal, which most homesteaders have lying around, the out-of-pocket drops to $12 to $20. Step 1. Build the shaft. Cut your plywood into 4 panels, each 16 inches wide. Screw them onto the 2x4s to form a rectangular column, 16 inches by 16 inches interior, 8 feet tall. You want the seams tight. Use construction adhesive on the joints if you have it. When it is done right, you can look up through the shaft and see a clean rectangle of sky at the top. No light leaks on the sides. Step 2. Cut the intake opening. At the top of one side, cut a rectangular opening roughly 16 inches wide by 12 inches tall. This faces your prevailing wind direction. If your wind shifts seasonally, cut openings on 2 or 3 sides and add internal dividers, vertical plywood panels that run diagonally from corner to corner inside the shaft. This is exactly what the 4-sided Yazdi Badgir uses. Each opening catches wind from its direction and channels it down its own quadrant. Step 3. Mount the shaft. The tower needs to sit on your roof, extending above the roofline. For a DIY installation on a shed, workshop, or small cabin, mount it over a hole cut in the ceiling, sealed with flashing tape. The bottom of the shaft opens directly into the room you want to cool. The higher the tower extends above your roof, the better the stack effect. 6 to 10 feet above the roofline is ideal. Here is the part that ruins 90% of builds. People skip the evaporative cooling element. Without it, you are just moving outdoor air through the room. That helps, but it is not the same as cooling. You need evaporation. Step 4. Install the cooling medium. Hang wet burlap strips inside the lower third of the shaft. Drape them over a simple frame made from PVC pipe or wooden dowels. The air flowing down the shaft passes through the wet fabric, picks up moisture, and drops in temperature. For the best results, the burlap should be damp, not dripping. Keep a 5-gallon bucket with a small recirculating fountain pump running water up to a drip line at the top of the burlap section. The pump costs about $8 at Harbor Freight or Amazon. If you do not want to use any electricity at all, just re-wet the burlap by hand twice a day. Step 5. Create the exhaust path. Your room needs an exit for the air. Open a window or door on the opposite side of the room from where the tower feeds in. Without an exhaust path, you build back pressure and the system stalls. This is the same mistake people make with whole house fans. Air in, air out. That is the whole system. Step 6. Insulate the sun-facing sides. If the south or west side of your tower gets direct sunlight, line the interior with 1-inch rigid foam board, about $4 for a small panel at Home Depot. This prevents solar gain from preheating the air before it enters your room. The Persians solved this with massive stone and adobe walls. You solve it with $1 worth of foam. For hot, dry climates like Arizona, Nevada, Utah, New Mexico, and West Texas, this system is devastatingly effective. Evaporative cooling works best when relative humidity is below 40%. The drier the air, the more water it can absorb and the more heat it pulls out. For humid climates like Florida or the Gulf Coast, skip the wet burlap. You are still getting ventilation and the stack effect, which can drop perceived temperature by 5 to 8 degrees through air movement alone. But the evaporative element will not help you in 80% humidity. It will just make things muggy. For a greenhouse, workshop, or animal shelter, this is a direct replacement for a powered exhaust fan. Same airflow, 0 energy cost. And the cooling effect is a bonus that no exhaust fan provides. Researchers Hijazi and Hijazi, publishing in the International Journal of Design and Nature and Ecodynamics, studied 4 wind towers in Kashan, Iran, at heights of 4, 6, 8, and 10 meters above the roof. They documented consistent indoor cooling performance with air mass flow increasing proportionally with tower height. The taller the shaft, the stronger the convection draw. A separate study published in the Journal of Building Engineering measured passive cooling power of 9.6 kilowatts from a wind catcher operating in wind speeds of just 4 meters per second, roughly 9 miles per hour. That is a light breeze. A typical residential window AC unit produces around 5 kilowatts. This tower, using no electricity, outperformed it by almost double. Between 1979 and 1994, nearly 7,000 variations of wind catchers were installed in public buildings across the United Kingdom, including the Royal Chelsea Hospital in London. Modern peer-reviewed analysis shows wind towers reduce building energy consumption by 23.3%. They provide up to 30 air changes per hour, exceeding the ventilation rates recommended by both CIBSE and ASHRAE. Now, the honest part, because this channel always gives you the full picture. This is not a replacement for central air in a sealed modern home in Houston. If you live in a hot and humid climate where outdoor temps hit 100 degrees with 80% relative humidity, a passive wind tower alone will not bring your indoor temperature to 72 degrees. The evaporative component needs dry air to work, and this is a structure that extends above your roofline. Check local building codes before installing. Most jurisdictions treat anything mounted to a roof as a structural modification. On a detached workshop, greenhouse, or barn, you are almost always fine. On a primary residence, you may need a permit. That said, these are boundary conditions, not flaws. In the 30-plus states where summer humidity regularly drops below 40%, this system does exactly what a 2,500-year-old civilization proved it would do. It moves heat out and cool air in using nothing but the shape of a box and the physics of evaporation. 2,500 years ago, a builder in Yazd, standing on a rooftop in 115-degree heat with no engineering degree, no electricity, no internet, figured out that you could cool an entire house below 80 degrees by stacking stones into a tall column and letting the wind do the work. He passed the design to his apprentice. His apprentice passed it to the next generation. For 100 generations, the knowledge moved forward through families, through trade guilds, through cities that stretched from Persia to Egypt to the Gulf. The Dawlat Abad Tower still stands today, 112 feet tall, built before George Washington was born, still cooling the garden beneath it. And somewhere in the middle of the 20th century, when the first residential air conditioners rolled off the assembly line, the knowledge stopped moving. Not because it stopped working, because it stopped making money. Now you have it back. You know that a $20 tower made from plywood and wet burlap can drop a room by 20 degrees. You know that the design is older than the Roman Empire. You know that the materials cost less than your next electricity bill. And you know what a $130 billion industry depends on you not knowing. Here is the part that stays with me. The physics have not changed in 25 centuries. The wind still blows, water still evaporates, heat still rises. The only thing that changed is who profits from your discomfort. If someone you know has been dreading their summer electricity bill, send them this video. They deserve to know there is a $20 option that does not require a single outlet. Knowledge like this does not disappear on its own. It gets buried. This channel digs it back up. If that matters to you, subscribe. New systems decoded every Tuesday and Friday. Thanks for watching. I will see you in the next one.